Now we're going to talk about aspect ratio and why it's important to consider aspect ratio for your heavy-duty industrial pavements. The American Society of Testing Materials sets forth the C936 standard for standard specification for solid concrete interlocking paver units. It has to have a maximum size of 101 square inches or less, with an overall length divided by thickness less than or equal to 4:1, so it means the 4:1 aspect ratio, and we'll talk about that here in the next few slides. And it has to have a minimum thickness of 60 millimeters. So this paver here is a 60 millimeter paver, so you kind of get an idea what this looks like. We'll talk about these other ones here in a few minutes. They also reference other standards in the C936 standard. So we'll talk about the C140 compressive strength in the next slide. The C1645 will take these pavers, we'll put it in a tank of water with about a 3% saline solution, and it can have a certain amount of dry weight loss, so it can't fracture, have pieces fall off to it. There's a maximum amount that's allowable. And then the C418 is how well that surface wears before it wears down and is no longer usable. But with the C936, the strength and durability is very evident when you look at these standards. So the minimum PSI is 7,200 for a unit with about an 8,000 PSI average, and the absorption is right around 7%. Now the Unilock standards are a little bit higher than that. We're about 8,500 PSI with about a 4% average absorption. Now many of these pavers you see on the table today will have PSI strengths well over 10,000, maybe as high as 12 or 13,000 PSI. But there is no flexural strength requirement for ASTM C936, which is how well that paver is going to work when you put heavy-duty applications on it. Now there's two different aspect ratios we want to talk about. There's the width to length aspect ratio and the thickness to length aspect ratio. We're going to focus on that thickness to length aspect ratio. That's most important for heavy-duty applications. So when you start to look at weight being applied to these surfaces, you want to make sure that these don't break in half. So there's some recommended guidance. As I mentioned in the C936, it says 4:1. So if you look at, like, for example, this 4x16 paver, that surface area is about 64 square inches, or just under 64 square inches, so it meets the definition of a paver. And you want to have that aspect ratio at 4:1, and that's exactly what this is. The inch, it's 4 inches thick by 16 inches long, so that's a 4:1 aspect ratio. Now when we look at this larger paver over here, this also is a 4:1 aspect ratio. It's 6 inches thick by 24 inches long, so that's your 4:1 aspect ratio. But this actually has 144 square inches on the surface, so it does not actually fit in the ASTM C936 standard. However, in our opinion, it also does not fit as a slab. So there's a little bit of a gray area there. That's why aspect ratio becomes very important for these heavy-duty applications. So the importance of aspect ratio in a flexible system. First, pavers need to be manufactured to that C936 standard, so it's a dry cast concrete mix and it's an unreinforced concrete mix, so it's susceptible to damage if used improperly. Any flexing or rocking caused by movement on the surface could cause those pavers to break if there's an insufficient aspect ratio, so we recommend certain aspect ratios based on the application. Breakage can compromise the system, so it's critical that you don't have breakage on that. You don't want to see any breakage in the system. And lastly, broken paver units are not aesthetically pleasing. It looks horrible, so we want to avoid that and make sure you get the right aspect ratio for the performance of your system. Now here's some examples I just want to mention. The 6x24 paver like this one over here was used out at the Navy Pier. So again, that's a 4:1 aspect ratio. And the reason was, if they have to drive emergency vehicles down the pier, they want to make sure they didn't have any breakage and have to repair this every time they had an ambulance or a delivery truck go down the pier. Now the exact same size unit, a 6x24, was used on this project here called Old Town Park, except this is only 7 centimeters thick. So the aspect ratio is 8.6:1, but the exact same surface area. Now this is only for pedestrian walkway, so it's not as critical to have a paver this thick, so there's some savings money-wise for doing that. Now some aspect ratios you can stretch a little bit based on the system you're designing. So this project here, this Hyatt Regency in Chicago, is set on a bituminous material over a concrete deck. So we're actually able to stretch this a little bit for vehicular traffic. So even though this aspect ratio is 5.71, this has been in for about 6 years and they've experienced no breakage, and that's because it is set on a bituminous material. Now, if you're using the improper aspect ratio for your application like this loading deck, this had some 6 by 36 inch 4-inch units with an aspect ratio of 9:1, and when they drove those forklifts across this area, it snapped all these pavers in half. So this was not a Unilock product, and we did not recommend this product for this use. About once or twice a year, we'll get people ask us, well, will these meet H loading or HS loading? And one of the things I want to point out is the importance of aspect ratio, because things like HS loading and H loading don't really apply to pavers. That is really mistakenly applied to pavement surfaces, really designed for bridge design. So H refers to highway 2-axle type vehicles. HS refers to highway semi, which adds an additional axle. And the weight between these axles is split from the front wheels to the back wheels. So like in this case, a 40,000-pound vehicle or 20-ton vehicle. And then the H20, as I just mentioned, refers to the weightage and tonnage. So if you look at this chart here that shows you the different weight breakdown for trucks, you can see they range from basically a 25-ton vehicle at 50,000 pounds down to the 15-ton vehicle. And again, pavers can support that as long as you have the correct aspect ratio for those uses. So if we do a quick little calculation here, just to give you an example of how durable pavers are and how much weight is applied during the H and HS loading and why it doesn't apply to concrete pavers. If we have a heavy-duty axle at 40,000 pounds, so you're looking at 4 tires on the back, each would support 10,000 pounds. If the pad that hits the footprint that hits the surface of the pavers is 9 by 9, which is about 81 square inches. So if you divide 81 into 10,000, you get about 123 pounds per square inch applied to the surface of that. Now the minimum Unilock compressive strength is 8,500 psi. So that really is only, with a factor of safety of 3 applied to it, about 4.3% of the total capacity. So when people ask about H loading and HS loading, that's not the most important thing to look at. You should be looking at the C936 standard for the compressive strength as well as the aspect ratio. And as we start to see more plank projects out there, you really want to consider that in all your applications for installations with heavy-duty traffic. If there's any questions, please reach out to your local territory manager or commercial rep. Thank you and have a great day.